Hello, welcome to today's webinar introducing our new product, SOFO Lite. My name is Daniele Naudi, I'm Chief Technical Officer at SMARTEC. This webinar will take about 20 minutes. You should hear my voice through your PC or speaker or telephone if you dialed the number provided with the invitation. You can ask questions during the presentation using the question panel on the right hand side of your screen, and we will answer those questions at the end of the presentation or by email later on. This webinar will start with a short introduction and history of the SOFO system. We will review the advantages of the SOFO sensing technology, and then we will introduce the new SOFO Lite reading unit, its specification, features and advantages. We will also spend a little time discussing different possible configurations of the SOFO Lite, and finally we will give a quick recap on other products that are part of the SOFO product line, in particular sensors, other readout units and the SDB software. A very short history of SOFO technology. SOFO stands for Surveillance des ouvrages par fibre optique. It's French for structural monitoring by optical fiber. It was developed almost 25 years ago at the Swiss Federal Institute of Technology in Lausanne, and 20 years ago in 1996 it was industrialized and commercialized by SMARTEC, so it was the first product of our company. It was also a pioneering technology in structural health monitoring, but over these 20 years it has become a very proven sensing technology with a track record of more than 15,000 sensors installed over those 20 years. The SOFO system is a long-range fiber optic deformation sensor. So it measures deformations over a measurement base that can be set between 20 centimeters and 10 meters with very high resolution and excellent long-term stability. Thanks to its construction, it is insensitive to temperature effects, electromagnetic fields, corrosion, and therefore is very good for long-term monitoring of structures. Sensor can be embedded or surface mounted on new and existing structure. They're easy and rapid to install and also to measure. The SOFO system has proven very useful for monitoring large structures, especially those made of concrete, and for geotechnical applications. The main advantages of SOFO sensing are, first of all, in the long gauge technology. Sensor can be made in any length up to 10 meters, and this allows to monitor large structures using a smaller number of sensors. The sensor can cover the whole length of a structural element. For example, if you have a column that is 3 meters high, you can use a 3 meter long sensor, or if you have a beam that is 20 meters long, you can use 4 sensors of 5 meters and cover the whole length of it. So the sensors are not sensitive to local defects. For example, if there is a stone or aggregate or a small defect locally, it will not influence the measurement. So it allows the monitoring of a concrete element as a whole. It is particularly adapted for the monitoring of concrete structures, but also for rocks and soil. The sensor is designed to be embedded in fresh concrete, but also surface mounted on new or existing structures, for example steel structures or masonry structure. Another very important feature is that the sensors are self-compensated for temperature, so these sensors have very low influence of temperature, and also they're very accurate and long-term stable. We have sensors that were installed 20 years ago that show no drift in the meantime. They are still working after so many years. So it's a very good technology for monitoring structures over many years. But today the focus of the presentation is the introduction of the new SOFO Lite readout unit. The new SOFO Lite readout unit is a new cost-effective interrogator. It allows monitoring of small and medium-sized projects with costs that are 20% lower than an equivalent Fiber Bragg rating-based solution. The readout unit itself comes with 10 or 12 channels that can be acquired simultaneously and can read all SOFO deformation sensors, including those that are already installed. It features the same high resolution, accuracy and long-term stability of previous SOFO interrogators, but also as an integrated data processing. As we will see, this offers some new possibilities in terms of controlling the SOFO Lite reading unit. The interfacing is done via an Ethernet interface that allows easy networking, and the readout unit is small, rugged, and has no moving part, with all connections at the front panel, so very easy to integrate, for example, in connection boxes. In terms of resolution, we still offer 2 micron resolution or better with a linearity of 2 per mil. We can measure all channels at 1 Hz, and in case of writing to the SDB software database, it takes less than 2 seconds per channel to take a reading. The measurement range is of 50 millimeters, so we can measure large deformations with long sensors, and you can connect 1 SOFO deformation sensor per channel. So SOFO Lite is not compatible with the SOFO splitters that are used with the SOFO 7 readout unit. As with all SOFO interrogators, there is no need to calibrate the sensor or the readout unit. The connections are E2000 PC, and as mentioned, we can offer this unit with 10 or 12 channels. Other specification includes DC power supply with very low consumption, so it's compatible, for example, with solar panel power supply. The external connection is with Ethernet. The dimensions are 28 centimeters by 16 by 11, weighs less than 2 kilograms, and can operate in temperature between 0 and 50 degrees C with non-condensed humidity up to 90%. Here's a couple of other images of the readout unit. As you can see, it's very compact and lightweight. The connections are at the front. On the right side you have the power supply, the Ethernet connection, and the status LEDs, and on the right hand side you have the 12 connections, optical connections, and also LED indicators that tell if the connection to the sensor is good. On the back side we have a DIN rail mount adapter, so that makes it easy to install in a cabinet or rack, for example. Here's a couple of pictures of test installation we carried out. In the left hand side you can see the SOFO Lite installed in a networking cabinet, so it can be connected directly to the Ethernet switch, and then the yellow optical fibers connect the readout unit to the sensors installed in the building. The SOFO Lite readout unit is based on a sophisticated algorithm that allows the measurement of SOFO sensor through spectral analysis. You can see that the SOFO sensor is made of 2 optical fibers. One, depicted here in red, is the so-called measurement fiber, is under tension between the 2 anchors and follows the deformation of the structures, while the second fiber, depicted here in green, is the so-called reference fiber that is loose and is used for temperature compensation. At the end of the 2 fibers we have mirrors reflecting light, and on the other side we have a coupler that splits and recombines the light. By sending a swept laser light into the sensor and measuring the reflected light from the sensor itself, we get a periodic structure as depicted in the bottom on the left, and through fast Fourier transform we can then obtain a clear signal that is proportional to the length difference between the measurement fiber and the reference fiber. Now if the sensor elongates, that difference will increase and we can measure it, but on the other hand, if temperature changes, it will affect both measurement and reference fiber equally, and so we get a 0 net result. So this explains why the SOFO sensors are not sensitive to temperature variations. The interfacing to the SOFO Lite happens through the Ethernet interface, and this allows different type of connections. It can be direct wired, it can be wireless through wireless Ethernet, and it can be remote through a VPN. In terms of accessing the data, we can either do it with the SDB software, our free software that is included with every readout unit, is used to acquire the data, manage the data, display and save in a database. And this software can be installed, for example, on a portable PC or an industrial PC that connects to the SOFO Lite through the Ethernet port. On the other hand, the SOFO Lite is also able to process the data on board and provide the result to third-party system, for example, a PC running another acquisition software such as LabVIEW or an industrial controller. So by using a protocol that we provide, you can get out the readings from the sensors directly without using the SDB software. So let's now see a couple of common configurations. This is the simplest one, with SOFO sensors connected directly to the SOFO Lite reading unit, and then the SOFO Lite reading unit connected with an Ethernet cable to the PC that is running the SDB software. In this case, we can then measure the sensor and obtain the measurements directly on the PC. Using the protocol that runs over Ethernet, it's possible also to use an industrial controller instead of the PC, and a different software that sends commands to the SOFO Lite reading unit and gets the measurements back via the protocol. Moving to more complex configuration, we can network multiple readout units, connecting them to an Ethernet switch, and then also we can have several data acquisition systems that connect to the units and obtain the measurement results. So this allows more complex configurations. For example, here, if we are monitoring a tunnel and SOFO sensors are installed in different sections of the tunnel, if those sections are relatively far from each other, it will be cheaper to install multiple SOFO Lite readout units instead of having a fiber optic cable concentrating all measurements in one single spot. So for example, if we have 3 measurement sections, like in this example, we can have 3 SOFO Lite reading units, and they're all connected together via an Ethernet backbone, and that Ethernet network doesn't need to be dedicated to the SOFO sensing only, but can be the infrastructure connection that is already available and used for other purposes in the tunnel. Here we have another example of a bridge application, a cable stayed bridge with 2 pylons. In this case, we could have a SOFO Lite readout unit in each pylon, and this has the advantage that those 2 units can be installed already during construction, even before the deck is completed, and they can be measured either locally, separately, or remotely via a wireless Ethernet interface. And finally, in the case of buildings, we can have a SOFO Lite readout unit in each building, measuring up to 10 sensors, and then this SOFO readout unit can be connected to internet connection and measured remotely. So this allows a lot of flexibility in terms of where to place the SOFO Lite units, and can therefore be used both for simple projects with just a few sensors, but also for bigger ones where using multiple units can be advantageous. Besides the new SOFO Lite reading unit, we are still offering our higher end readouts. The SOFO 7, depicted on the left, is our readout unit that is able to measure both SOFO and Fiber Bragg Gratings sensors with up to 4 or 8 channels, and on each channel you can have multiple SOFO sensors up to 5 and multiple Bragg Gratings up to 10 or 20 depending on what you measure. The SOFO 7 also has a built-in PC. And on the right hand side you have the portable reading unit with touchscreen running SDB on board, so that's very useful for short-term projects or during installation of the sensors. The SOFO sensors themselves have not changed. It's a very proven design and technology. It can measure on measurement base between 20 centimeters and 10 meters, 1% elongation and 0.5% compression, and as shown in the 2 pictures, can be either embedded in concrete or surface mounted, for example on a steel structure. The SOFO Lite also comes with the SDB software. It is fully compatible with all our data acquisition systems, so besides SOFO it can also measure FISO sensor, SenseLog and 3Daemon. It can schedule measurements to perform them automatically, and all projects results are stored in a single database. We can also display directly the sensor history. We can calculate macro sensors based on calculation on different sensors, and we can export the data. Here's a picture of the SDB software showing a time history of a sensor on a graph. Here we have an example of a map where you can superimpose the measurements on a picture or a drawing of the structure and use color coding to show the level of measurement compared to some predefined thresholds. And finally, the Pro software that allows the creation of macro sensors, combining the measurements from several sensors into a mathematical formula, much like you would do in Excel. And then these formulas are updated automatically when new measurements become available. The application domains of SOFO technologies are very varied. Of course, bridges, buildings and tunnels, and in general concrete structures, but also dams and levees and geotechnical structures in general, like deep excavations. It has been used also for monitoring mining operation, local deformation of pipelines, and we have versions of SOFO sensor that can be used in cryogenic environment, nuclear environment, and for monitoring ships. So this brings me to the conclusion of my presentation. Today we are introducing a new SOFO readout unit called SOFO Lite. It's a very cost-effective solution for small projects or where networking of several readout units is advantageous. It comes with 10 or 12 channels, allowing simultaneous acquisition of all of them. It's a reliable and versatile data acquisition unit for field application, packaged in a small rugged housing with no moving parts. It reads all SOFO deformation sensor with high resolution, accuracy and long-term stability, has integrated data processing, and can be controlled via Ethernet interface for easy networking. So this brings me to the conclusion of today's presentation. If you need more information and if you like to have one SOFO Lite at your place for a demo or a trial period, please contact us at info@smartec.ch, and in the address indicated below you can also find the datasheet of the SOFO Lite reading unit. And that's all for today's presentation. Again, if you have any question, please use the question panel on the right hand side, and I will be here a few more minutes to answer those questions. Thank you very much.